Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video is the first of two parts of the series Trigonometric Identities. It is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. It is recommended to view the video Trigonometry and the Unit Circle before watching this video. In this video, we will be discussing the definition of identities, basic trigonometric identities, Pythagorean identities, and even and odd functions. An identity is an identically equal relationship between two functions. F of x is equal to g of x for every value of x in which the functions are defined. An equation that is not an identity is called a conditional equation. The understanding of the identity relationships between the trigonometric functions will be useful when continuing study in higher level mathematics. We begin with the basic identities that are formed from their respective definitions. These are identified with a right triangle. First, designate one non-right angle as theta. The side opposite the right angle is the hypotenuse. The side next to the angle theta is called adjacent, and the side away from the angle theta is called the opposite. Sine theta is defined as the opposite side over the hypotenuse. Cosine theta equals the adjacent side over the hypotenuse. Tangent theta equals the opposite side over the adjacent side, which means that tangent theta also equals sine theta over cosine theta. Cosecant theta equals the hypotenuse over the opposite side, or 1 over sine theta. Secant theta equals the hypotenuse over the adjacent side, or 1 over cosine theta. Cotangent theta equals the adjacent side over the opposite side, or 1 over tangent theta, or cosine theta over sine theta. With the trigonometric functions defined, we can use them to establish identities between two different functions. For example, is secant theta times sine theta equal to tangent theta? Secant theta equals 1 over cosine theta. This times sine theta equals sine theta over cosine theta, which we have previously established as equal to tangent theta. As a second example, show that secant theta plus tangent theta over cotangent theta plus cosine theta equals tangent theta secant theta. First, let's express secant theta as 1 over cosine theta, tangent theta as sine theta over cosine theta, and cotangent theta as cosine theta over sine theta. Next, we complete the addition in the numerator. Since it has a common denominator already, we get 1 plus sine theta over cosine theta. In the denominator, we can multiply the second term by sine theta over sine theta to get sine theta as the common denominator. Next, we complete the addition in the denominator and factor out cosine to get cosine theta times the quantity of 1 plus sine theta over sine theta. Next, we resolve the compound fraction to get 1 plus sine theta over cosine theta times sine theta over cosine theta times the quantity of 1 plus sine theta. The 1 plus sine theta terms cancel, leaving 1 over cosine theta times sine theta over cosine theta, which equals tangent theta times secant theta, confirming the original identity. Using the Pythagorean theorem, we can arrive at other identities. As a review, we again start with the right triangle. This time, Pythagoras gives us the equality a squared plus b squared equals c squared, where a and b are the lengths of two sides and c is the length of the hypotenuse. We've already established that sine theta equals the opposite side over the hypotenuse, or on this triangle, a over c. And cosine theta equals the adjacent side over the hypotenuse, or b over c. If we divide all terms in the Pythagorean equation by c squared, we get a over c squared plus b over c squared equals 1. Substitute a over c for sine theta and b over c for cosine theta to get the identity sine squared theta plus cosine squared theta equals 1. If we take this identity and multiply both sides by 1 over cosine squared theta, we arrive at tangent squared theta plus 1 equals secant squared theta. Likewise, if we take the original identity and multiply both sides by 1 over sine squared theta, we get 1 plus cotangent squared theta equals cosecant squared theta. As an example, let's use the Pythagorean identity to establish that sine theta times a quantity of cotangent theta plus tangent theta equals secant theta. First, we write cotangent theta as cosine theta over sine theta, tangent theta as sine theta over cosine theta. Next, distribute sine theta to get cosine theta plus sine squared theta over cosine theta. Then establish the common denominator of cosine theta to get cosine squared theta plus sine squared theta over cosine theta. Since cosine squared theta plus sine squared theta equals 1, then 1 over cosine theta equals secant theta, which is correct by the definition of secant theta. Next, let's evaluate the trigonometric functions and relate the negative functions to the positive. For this, we will use the unit circle. For all sine functions, note that sine is positive in quadrants 1 and 2. This means sine of all negative x's is equal to negative sine of x. This makes sine an odd function. Since cosecant is 1 over sine, it is also an odd function. Conversely, cosine is positive in quadrants 1 and 4. This means that cosine of every negative x is equal to cosine of x. This means cosine is an even function. Since secant is 1 over cosine, the same is true for this function as well. For tangent, we consider that tangent negative x equals sine negative x over cosine negative x. Sine negative x equals negative sine x, and cosine negative x equals cosine x. Therefore, tangent negative x equals negative tangent x. Therefore, this is an odd function. Since cotangent is 1 over tangent, the same is true for this function as well. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.